Good morning, everyone. My name is Mohammad Zaki Alwadkar, and uh, today I am going to tell you about CGV topic, that is template matching mask, which is an edge detection algorithm in which we are going to learn about Frei-Chen mask. So in that template matching algorithm, we are going to learn about the this is a content where what we are going to learn about: introduction to template matching, types of template matching, introduction to Frei-Chen mask, example of Frei-Chen mask, advantages and disadvantages of Frei-Chen mask, and results of applying the Frei-Chen mask. The, this These are the contents which are we are going to see now. So introduction to template matching. In introduction to template matching is an edge detection algorithm, as the classification diagram is shown here. The edge detection algorithm, in which there are four types. First one is derivative types template matching, then Gaussian derivatives, then pattern fit approach, from which we are going to learn about template matching algorithm. The gradient masks are isotropic and intensive to direction. Sometimes it is necessary to design direction sensitive filters. Such are called as template matching filters. Means template matching filter are used for isotropic and intensive to direction. It is necessary to design direction sensitive filters. Such it is called as template matching filters. So in that we are going to learn about Frei-Chen mask. There are three types of template matching algorithm. So first one is Kirschich mask, then second one is Robin compass mask, and the third one is Frei-Chen mask. These are the three types of different template matching mask categories, from which we are going to learn about Frei-Chen mask. This is the Frei-Chen mask which we are going to learn, and afterwards then. So introduction to Frei-Chen mask. Any image can be considered as a weighted sum of 9 Frei-Chen masks. Means any image, if we are having an image, then it is divided into 9 Frei-Chen masks. The weights of that 9 Frei-Chen masks are processed, called a projecting process, by overlaying three images onto each mask. For example, if we have an image, then it is divided into 9 Frei-Chen masks. By applying Frei-Chen mask algorithm, the image is divided into 9 Frei-Chen masks by overlaying a three image onto each mask. Uh, if an image is if one image is having, there will be three overlaying mask, Frei-Chen mask of a single image. There are three overlaying mask image onto each mask by summing of multiplication of coincidence terms. The three overlaying of that mask is been the summing of that mask of that coincident terms. The first four represent the edge space, the next four represent the line subspace. The first four masks of that overlaying Frei-Chen mask are represented as space mask. For example, in the next slide we are going to see that example. The first four mask is considered as space mask, and the next four is represented as subspace. Means the first four as considered to be as main space, and the next are considered as subspace, and the last one represent the average subspace, and the last one is represented as average subspace. Means the first is main space, and the second is subspace, and last one is average space. The Frei-Chen masks are given as so we are going to see now going to see the algorithm example. So first four are represented as space mask. Means f1 1 upon 2 root 2 1 root 2. These are the matrix which these are the matrix, means the in which by which we have seen in the previous slide. These are the matrix which is called as subspace, main space. The first four f1 f2 and f3 and f4 are considered as main space, and f5 f6 f7 f8 and f9 are considered as subspace. In this, the first four matrix are used as a layer mask, and next is considered as sublayer mask. The matrix are as shown below: 1 upon 2 root 2, 1 upon root 2, 1 0 0 0 minus 1 minus 2 minus 1, f2 equal to 1 upon 2 root 2, 1 root 2, 1 0 0 0. From this matrix, the I2 is considered as the index 2 is considered as the second layer, and here it is being uh, verticed. The vertices are changed. The middle I2 is considered as 3 zeros 0 0 0, and next we are going to see a diagonal zeros, that is 0 0 0, from which first it is considered 1 upon 2 root 2, 0 minus root 2, 1 0 minus 1 root 2, 1 0 1 1 0. Here the zeros are as diagonals, means the second layer is not considered, and here the I2 indices are 0, and here it is represented as diagonals, means every indices are represented, and here it is in relative manner. And next is F5, F6, F7 and F8, which is a submass. Here everything is represented as a 0 0. Here the two diagonals are two lines, that is I2 and S2 are 0 and 0. And here in F7 we are representing all the mask, that is minus 2 minus 2 minus 2, 1 1 1 1, and the middle one is 4. And after that we are seeing minus 2 minus 2 minus 2. The I2 and S2 are represented as 1, and the middle one is 4 only, as same as F7. And after that F9 we are going to see all the results, that is 1 1 1 1, which are the final image we are going to see. This is the image representation, how we are going to represent the image. uh, the layers are divided into these types, and at the last we are going to get the final product. And next we are going to see about advantages of Frei-Chen mask. The first advantage is edge detection, means with the help of Frei-Chen mask we can detect the edges of the image, identifying a specific pattern with an image. The next is simple implementation. It is easy to implement. The Frei-Chen mask algorithm can be easily implemented using convolution. It is directional sensitivity. The mask can detect edges in multiple directions. If an image is having multiple edges, then it can detect at multiple direction and multiple edges. And next we are going to see about disadvantages of Frei-Chen mask. So computationally intensive. Applying multiple masks to an image can be computationally expensive. It may, for example, if the image contains of multiple masks, then the expense of identifying it is also the identifying is also more. And next is fixed size. The mask of a fixed size and may not perform well images with varying scales. If an image is of not that form of size, then it may expand or it may collapse. So the Frei-Chen mask consists of fixed size, which is a big disadvantage. If the image is big, then the pixels of that image will be uh, towed. And the next is sensitive to parameters. Performance can be sensitive to choice of thresholds. The performance may vary if the choice is if the parameters are big or small. The parameters may change, requiring a fine tuning. Performance can be sensitive to each choice of thresholds. And the next we are going to see about the results of that Frei-Chen mask. For example, here is a flower image. Here is a flower image, and here is a masked image of that flower. Here we can see the images clearly, but in this process we are seeing the mask image of that product. So this is what we are so this is how the Frei-Chen mask is being used. For example, here the flowers are being in colorful manner. Here it is not showing the color of that flower, it is just showing the outline of that flowers. Thank you.